Welcome to Graphing Quadratics number 3. Today we are going to find the vertex of a parabola given equations. Again, that's what we've done in two different note sessions. And we are going to expand that into some word problems. So we have already seen the standard form of a quadratic equation. Y equals a times x squared, the quadratic, plus b times x, the linear guy, plus the constant. And we already know that the vertex formula is x equals negative b, or opposite of b, over 2 times a. And we know that the vertex is going to be x comma y. That is the location of the vertex. So step number 1, we find the x right here. And then step number 2, we find the y. So in order to find the x, we use opposite of b over 2a. And then to find the y coordinate, in our last video, we discussed that we have 3 different tools that we can use to find the y coordinate. So there are 3 different tools. One tool is Desmos. Another tool is your graphing calculator. And another tool, trusty dusty, algebra. Okay, so there are different situations on when it's best to use Desmos or it's best to use algebra. So that's kind of is going to be my focus. I know that you can find a vertex point at this point, but I want to focus in on how would I know when I should be using which method. So that's what I'm going to do in the margin here. So I kind of want to do a rule for y. Okay, so this is kind of how we are going to break it down. If x is an integer, remember what an integer is? That is a whole number, both positive and negative. So if x is an integer, that means that we get a really nice value for x, like 17 or negative 3. If x is an integer, then your quickest way is to use the Desmos, D-E-S-M-O-S, the Desmos graph. And all you have to do is just click on that point and it'll tell you what the coordinate is. So if x is an integer, if it's really nice looking, your best way is to just put it on Desmos and then you can click on the graph on that vertex point. Okay, what else could happen? If x is not a nice decimal, so you get an x that would be like 0.33333333, and you have to write that as a fraction. So if you get something that's not a nice decimal, which means that you have to write it as a fraction, then you must be using algebra in order to do that. You know how to do that and plug in on your calculator. I'm going to show you that even if you don't have a graphing calculator, you can do this on Desmos as well. It's very cool. So I'm excited to show you that today. So if we get not a nice decimal, which means that it has to be a fraction, then we just need to go straight to algebra. And then if you get on Desmos, and if it uses 3 decimal places, then you don't know if that is an exact answer or not. Desmos only shows you 3 decimal places. So that means that you are going to have to check that answer with your algebra. Algebra will always give you an exact amount of decimals. It will change it back into a fraction for you. So if we are using Desmos and it gives us 3 decimal places, I am not confident that it is exactly 3 decimal places. Maybe it was war and it got rounded. And that means that we need to check our answer with algebra. And do not fear about algebra, because I will show you how to use Desmos to do that as well. Okie dokie. So let us do number 1. It says find the vertex point. And I'm going to scratch off algebraically here because I want us to use the best tool for the job. So find the vertex point, identify it as a max or a min, and then state the range of the function. Okay, so first things first. That's a negative. Negative means frown. Frown means maximum value. Actually, I'm just going to do this to all of them. That's a positive. Positive means smile. Smile means minimum value. That's a positive. Positive means smile. Smile means minimum value. That's a negative. Negative means frown. Frown means maximum value. Okay, being super efficient today, right? Okay. So now let's go ahead and find the vertex. So I'm going to do x equals the opposite of b over 2 times a. So that is going to be 2 over a negative 10. That's negative 2/10, which is negative 0.2. That's a nice decimal. So I feel confident in going to Desmos. When we get nice numbers, you can just put it in on Desmos. So y equals negative 5 x shift 6 square it, arrow out, minus 2x minus 6. So if I click on my vertex point right there, then I am only getting 1 decimal here. So that is an accurate, exact negative 5.8. I'm not going to have to double check this. I know for sure that my vertex is located at negative 0.2 comma negative 5.8. So that is my vertex. And then it says state the range. So the range is the y values. Because this is a frown, the frown is going to go down forever. That means negative infinity. And it's going to go all the way up to its maximum value. And that maximum value is located at a negative 5.8. If you prefer, y's have to be less than or equal to a negative 5.8. So that is the range. Easy peasy, right? Get a nice number, plug it into Desmos, click on the point, and then write your range. Let's do number 2. Number 2, gonna find the vertex. So opposite of b, so positive 24 over 2 times a. So that's going to be 24 divided by 8, which is a very nice 3. So that means that I'm going to go straight to Desmos. I've got a nice number to work with, and I am going to make that a 4x squared, a minus 24x, and then I'm going to get rid of that. Okay, so scrolling, dragging, grabbing, zooming, and here is my vertex. So 3 comma negative 36 is the vertex. This is a smile. So that means that for your range, we always go from small to large. The smallest point is right here at its minimum value. So the minimum value is negative 36, and a smile is going to go up forever, which is positive infinity. or if you prefer, your y values have to be bigger or equal to a negative 36. Nice, easy x means a nice, easy y. All right, let's take a look at number 3. Again, remember, pause the video, work out ahead of me, play the video, and then check yourself. All right, so I've got x equals opposite of b over 2 times a. That's going to be negative 11/12. And negative 11/12 I don't believe is very nice. Negative 11/12 is not nice. So that means that I have to use algebra on this one. I have to use algebra. So you know how I can put it in on my calculator. I want to show you that you can do the same thing on Desmos. Check it out. All right, so I am using algebra. So I'm going to go 6 parentheses, that's shift 9 to set up parentheses, negative 11/12, arrow over to close your parentheses, and then shift 6 to square it, and then arrow out of the exponent, plus 11, shift 9 to set up parentheses, negative 11/12, arrow out to close your parenthesis, minus 12. So just like I would have done it in my calculator, but I'm doing it on Desmos. Check it out. I put in a not nice decimal and I'm getting a not nice answer. I can't write that. I don't want to round it, but kiddos, do you see right here? I'm going to take that decimal answer and I'm going to click right here and it's going to change that into a fraction. Boom. So that means that my vertex was at negative 11/12, comma, and then Desmos converted back into a fraction for me. So negative 409 over 24. That way I have exact answers here. I have exact values. Let's see, the range, this is what? I don't have it graphed on Desmos, but I know that this is a minimum value. That means that this is at the very lowest point. It is the minimum value. So negative 409/24, and it's a smile, positive is a smile, so it's going to go all the way up forever to infinity. Or if you prefer, your y values have to be bigger or equal to negative 409/24. How cool was doing that right here on Desmos? So you can use Desmos as a calculator as well. Super cool. All right, let's take a look at number 4. So number 4, I'm going to use x equals opposite of b over 2 times a. So that's going to be 3 over a negative 2, and I know that that is negative 1.5. So I'm thinking that that is going to be an okay enough decimal to put into Desmos. Y equals negative x squared minus 3x plus 6. Let me drag here, and that is my vertex right there. Desmos is only giving me 2 decimal points, so I can be certain that that is accurate. If it was giving me 3, then I would question on whether that was giving me a rounded answer or not. So because it's only 2 decimals, I have confidence that this is negative 1.5, comma 8.25. That's the vertex. Because this is a frown is going to go down forever to negative infinity, and it's going to go all the way up to its maximum value at 8.25. If you prefer, your y values have to be less than or equal to 8.25. Okie dokie. So hopefully that was helpful for you in trying to determine what method to use. So you can do your algebra here, or you can do your algebra on Desmos. It is the exact same thing. I would say probably entering fractions in on Desmos is going to be a little bit easier than the calculator, just because it automatically stacks those fractions for you. Okay, so now we are into application problems. So application problems are just word problems. You need to read the scenario and figure out what is happening. And what we're going to want to do is we are going to want to draw a picture of what is happening. Drawing a picture allows us to get our X values and our Y values labeled correctly. So it says that the trajectory, that means that the path of a basketball when shot can be modeled by this equation, where B of X represents the height of the ball and X is the distance the ball is from the player. So I'm going to draw this. Here is my basketball player, and he is going to shoot a basketball. So it would go up in the air like that, and then it would come back down to the ground. So here is my X values. And then here are my Y values. So as I'm looking at my units, I've got B of X is the height of the ball. So the y-axis is height. So this is height represented by B of X. And then I am given X is the distance the ball is from the player. So this X measures the distance in X that the ball is from the player. Part A says, what is the independent variable X and what is the dependent variable Y? Well, the independent variable is X, right? Which is the distance from the player. And then that makes the dependent variable Y, which in our situation here is labeled as B of X, and that just represents the height of the ball. Okay, so we've got an X and we've got a Y, which is actually B of X. So I have my picture, which helps me determine who is X and who is Y, who is the independent variable, who is the dependent variable. So the distance away from the player and the height of the ball, the height is dependent on the distance from the player. All right, so part B says, find the vertex of this function and interpret the meaning of the vertex in a complete sentence. Okie dokie, so to find the vertex, how do I do that? X equals the opposite of B over 2 times A. So that is going to be -3 over -0.16. 8 times 2 is 16, so 0.16. And if you don't have a calculator in front of you, remember your Desmos can do that. So -3 divided by -0.16, and that is going to give me 18.75. Okay, so what does that mean? So I'm going to go ahead and graph this, and -0.08x squared. Whoops, I forgot my y equals. Y equals plus 3x plus 6. So I'm going to drag, and my vertex is right there. So X is 18.75. Y is 34.125. Okay, so I'm a little bit worried that those 3 decimals have been rounded. How can I double check that? I can plug my 18.75 into my equation. So what was it? Negative 0.08 parentheses 18.75, close it up, square it, arrow out, plus 3 parentheses 18.75, and then plus 6. Okay, cool. So this confirms right here that it is truly 3 decimal places. Okay, so I feel good about that. So let's go back to what this means. What does the X mean? The X means distance from the player. Distance from the player. What does the Y value mean? The Y value is the height of the ball. So if I need to explain what the vertex is, so the vertex is 18.75 comma 34.125, and I have to explain what that means in a sentence, it's going to look like this. When the ball is 18.75, what are my units? Does it tell me? It does not. When the ball is 18.75 units from the player, the ball is 34.125 units high, or above the ground would be fine as well. But that is your complete sentence. So long as I'm labeling what X and Y mean, when I get my vertex, I can transfer that into words based on what it means. All right, let's take a look at number 2. An apple is launched directly upward at 64 feet per second from a platform that is 80 feet high. An equation to model the path of the apple after being launched is this, where h of t represents the height in feet and t represents the time in seconds. Okay, so I'm going to draw out what this would look like. So we have an apple. Let me do my ground first. We have an apple that is being launched from an 80-foot high platform. So here's the platform. The apple gets launched into the air and then at some point is going to hit the ground. It says that h of t represents the height in feet. So that means that our y-axis is height in feet, and that is h of t. And then it says that t, so this is the x-axis, t represents the time in seconds. So time is t, which is the same thing as x. Okay, so that's my picture. What is the independent variable x? So the independent variable, here's my x-axis, so that is t, that is time. And then the dependent variable, that's y. Y is over here, and y represents the height, which is h of t. So we've got our independent, and then we have our dependent variables and what they mean. Okay, so that's the time that has passed, and that is the height of the apple. It says B, find the vertex and then write the meaning of the vertex in a complete sentence. All right, so here's the vertex. X equals opposite of B, right there, over 2 times A. That's negative 128 over a negative 32. And when I divide that out, that is 4. All right, let me put that into Desmos. I'm going to change this to a negative 16. I'm just going to leave it as x squared. You don't have to change it to t because t's and x's, they are the same. They represent the same thing. They are interchangeable. So 128x, and then I need that to be a plus 80. All right, so let me find the vertex. Oh, there we go. It's getting more narrow, so I'm dragging. Holy smokes, this thing is going way up there. Oh, you know why? Because that's a 0.16. I'm like, that, okay, that apple, like, think about how high that is. Holy smokes, are like going higher than planes fly? Like, I don't think so. Okay, so let me get rid of that decimal. I guess you have to be very, very careful when you are editing an existing equation. You could get into big trouble from that. So this seems much more reasonable that an apple would go 336 feet in the air. All right, so y is 336. Okay, so the vertex is at 4, 336. So we have to write what this means in words. So think about it. X was the amount of time in seconds, right? So that is time in seconds. And then Y was the height, and height was in what? I have to go back where h of t represents the height in feet, or I could go back here where I labeled it. So this is the height in feet. Okay, so now we can say that the vertex says that at a time of 4 seconds, or after 4 seconds have passed, the apple reaches a maximum height of 336 feet. Okay, so it's a maximum height. That's the highest that the apple goes. Oh, I'm sorry, you can't see that. At a time of 4 seconds, or after 4 seconds have passed, that means that the apple is at its maximum height, which is 336 feet in the air. So I know everybody's always scared by word problems, but if you draw your picture, okay, and you label the different parts of your picture, then these are really no big deal whatsoever. Okay, last one. The profit a company earns can be modeled using the quadratic function that, where P of X represents the total profit and X represents the selling price of the item. Okay, so the y-intercept, let me go back to this one. The y-intercept is always that plus c. The constant is always the y-intercept. So Apple was launched from 80 feet. So the y-intercept here is going to be negative 1200. The y-intercept is going to be at negative 1200. So let me draw a picture of this. So if that's the ground, or 0, that means that this profit, we are starting way down here at negative $1,200. The profit, so this is total profit. It is represented by P of X, and clearly profit means dollars. So that means that we are starting off our business in the negative. Well, why would that be? Well, whatever they're selling, they had to buy, right? So if they've already bought it, then that means that they have already spent money, which means that cash has already come out of the account and they are negative. So what's going to happen is they're going to start selling. They're going to make money back. This right here is the break even. That means that they haven't lost any money, but they haven't gained any money. The point is to make it past the break even, in which you will get your maximum amount of profit. And then there comes a point where your profits will actually come down and be back at zero again, or worst case scenario is that your profits go back into being negative and then you're not making a profit at all and your business is failing. So total profit here, X's, those are Y's, X's represent the selling price of the item, and that is also money. So the selling price of the item. Okay, so what is the independent X variable? So the independent is going to be X, which is the selling price of the item. And the dependent variable is this right here, the Y, that is P of X, which represents the total profit. So selling price of the item is X, and then P of X, that is the total amount of profit. Okay, find the vertex point. So X equals opposite of B over 2 times A. So that's negative 1400 over a negative 20. So that is going to be a positive. If I knock out a 0, 140 divided by 2, that's going to be 70. All right, let me come this way. And I need to be more careful this time. This is a negative 10x squared plus 1400x plus, nope, minus 1200. Okay, so let's take a look here at the graph. So if I go all the way down here to a negative 1200, negative 1200, right there, you can see that negative 1200, 0 in the X, that is the Y-intercept. So that's what we said before. Okay, let me go back in the other direction. So I'm going to follow this quadratic all the way up to its maximum. Wait, what is it? Ah! Oh my gosh, I'm losing it. I'm losing control. I don't know what is happening to my mouse. It's not allowing me to, it's doing a weird, I don't know what's happening. Oh my gosh. Why is it doing like this thing where I click on it, but I can't drag? I don't know what the heck. Okay, well, that is super duper annoying. Super duper annoying. Okay, so I'm over that, and I'm just going to use algebra, I guess. So negative 10. Maybe if you guys figure out what in the world happened to my cursor, you can, oops, you can let me know so that I can fix it, because I'm not doing that. I guess this is good because that could happen to you as you were taking your test. And if you can't figure it out, like the teacher in the room can't tell you how to fix your technical difficulties unless it's a problem with the computer. I mean, I guess technically that is, but it's with the application of something. So you would be stuck on your own. That would suck. Okay, so the good news is that I can just go back to algebra, because algebra always works, and that is going to give me a y value of 47,800. So that means that we have a vertex of 70, 47,800, and now I need to write this in a sentence. What does that mean? Well, what does X mean? X means the selling price of your items, and Y is a dollar amount, and that is your total profit. So if we put that into a sentence, that means that when the item selling price is $70, that means that you have a maximum profit of $47,800. That's what that means. If anybody figures out what the heck was happening with my dragging of Desmos, send me an email or a comment and let me know, because that was ridiculous. But anyways, it's okay because we just used algebra instead. Cool. Talk to you soon.